Good day everyone, I am Blessy Bondok from Mpe7 2D and this is my activity 1 in Mpe7 and I'm going to answer the following questions. First is, what are the major components of an open loop system? How does this type of control system differ from the closed loop system? And describe how each of the components of the open loop control system might function for a person who is tossing an empty soft drink can into a recycling bin. The major components of an open loop control system are the executive and the effector. And the difference between open loop control system and closed loop control system is that the closed loop control system has a feedback for and comparator, while the open loop doesn't, only executive and the effector. And closed loop control system has the ability to self-correct, while the open loop control system doesn't. And consequently, closed loop control system are often called feedback control sometimes, while open loop control system are also known as non-feedback control. And there is an example here that a person who tossing an empty soft drink can into a recycling bin. And I'm going to define how does each component of open loop control system might function in this action. So we all know that the two components of an open loop control system are the executive and the effector. So the executive is a command signal of a person who planning to toss the empty soft drink can into a recycle bin, and because of executive is a response selection and response programming, in other words, that is a decision maker or the determined action to be taken, maintain the desired goal. And the effector here is when he tossing an empty soft drink can, because the effector is the one who carries out the direction given by the executive. Next question is, how do we know that the motor program exists? Discuss two of the three types of research evidence that suggests support for the motor program motion, and how research illustrates that individuals plan their movements in advance. So, how do we know that motor program exists? So, let me discuss to you the evidence that support the existence of motor programs. First is the result of largely 1917 and more recent Taube Berman in 1968. The appreciation research have shown that the movements are possible without sensory feedback from the responding limb. Some movements, such as the involved in the climbing, swinging, and grooming in the monkeys, are controlled well without feedback, whereas after such a figure, movements show serious disruption. The major point, however, is not how much they are disrupted under their condition, but that the movement can occur at all. These findings support the motion that some central representation not absolutely dependent, and one response product feedback is responsible for movement control. At the same time, this data weaken a large class of models, emphasizing chaining of response feedback produced from the prior part of the chain. Example is James 1890 of closed-loop models based strictly on error nulling. Adams 1971. A second line of evidence suggests that sensory information process is too slow for effective moment-to-moment control is uh, rapid movements suggested that we response produce feedback are very sensitive to feedback delays and will oscillate uncontrollably feedback if delayed too much. Particularly so if the feedback loop is large. Although response produced sensory feedback undoubtedly plays a role in slower ongoing movement. Example is steering a car. It is unlikely that quick response can be controlled in this way. Considerable evidence show us that subjects who are suddenly and expectedly asked to change movement in progress, Henry and Harrison 1961, or to about it complete Logan 1982, Slaughterhammer 1960 cannot change the movement response before approximately 200 ms has elapsed, and presumably the movement is being controlled by some motor program. In the meantime, the existence of motor program is further strengthened by the findings from the research on the control of rapid limb movements. And this experiment record electrical ability from the contacting muscles via electromyography or EMG to show that muscular patterns are structured in advance by motor program. Next question, how do humans produce novel movements? Are such movements really new? Provide an example of a novel movement that might be produced by a shuffleboard player, a professional golfer, airplane pilot, or a wheelchair basketball player. According to Roller et al. 2012, the production and control of human movement is a process that varies from a simple reflex loop to a complex network of neutral patterns that communicate throughout the central nervous system and the peripheral nervous system. New motor patterns are learned through movement interaction with rich sensory environments and challenging experience that challenge a person to solve problems they encounter. The knowledge about motor central and motor learning shape our understanding of how individual progress from moving to skill and motor for performance through the lifespan. The novel movement of a shuffle player, a professional golfer, an airplane pilot, and a wheelchair basketball player is they all use their arms and hands, and they swing their arms to execute movements with balance and control. Next is what is generalized motor program? Indicate how this content allows us to explain the way performers adjust their movements to meet different sets of environmental demands. Using the example you selected in the previous question, explain um, how the generalized motor program might function to produce the performer's novel movement. Um, the generalized motor program is a motor program for a particular class of action. Is stored in memory that a unique pattern of activity will result whenever the program is executed. In order for the program to be executed, certain parameters must be supplied to the program that define how is to be executed on that particular trial, because the progress is output in terms of movements of the limbs can be allowed movement according to the parameters chosen on a particular trial program is required to be generalized before depriving how such a system might operate. It will be helpful to encounter an example of generative motor program is thought to be responsible for the production of a pattern of action expressed in both space and time. When patterns of action are examined carefully, we see that the various aspects remain almost completely fixed from movement to movement. It is not obvious which aspect of the movement are fixed and which are easily changed. The function of generalized motor program in the production of performance novel movement is their action is stored in memory, and that unique pattern of activity will result whenever the program is executed. Just like the pilot, there's so many different wrists and hands and arms movement he execute to fly, and he perform it correctly with the use of his brain. Another example is the professional golfer. Even if the golfer players' eyes are being blindfolded during the game, they execute a proper movement, and can be observed that the movement of the player doesn't change. Also, the wheelchair basketball player is being blindfolded during his game. The movement also doesn't change, and the speed and only the speed will change. That's all. Thank you.